In this video, I would like to go over the counting principle, which is the topic in 9.6 of our textbook. Now, in this section, 9.6, I will be doing a few or multiple videos, and this is the first one, part A. Okay, well, the counting principle is a big idea in this section, and the counting principle states that if event 1 can occur in m number of ways, and event 2 can occur in n number of ways, both event 1 and event 2, for them to occur together, that can happen in m times n total number of ways. Okay, well, let me show you a few examples. Okay, so for example, in the scenario where you have a particular closet with the following items inside. You have three kinds of shirts, a red, blue, and black, 2 pairs of pants, black and brown, and 2 pairs of shoes, dressy and casual. If I want to know the total number of outfits I can make with any of one of these combinations, and the way that I define an outfit is that if you have a red shirt, black pants, dressy shoes, that's a different outfit than red shirt, black pants, and casual shoes. Okay, so all right, so for shirts we have 3 options, and I'm going to put the 3 here and multiply that times the number of total options for the pants. And when it comes to the pants, there's 2 options, so multiply that by 2. And when it comes to the shoes, there's 2 options, so multiply that by 2. And the total number of possible outfits, it's 3 times 2 times 2, which is 12. 12 possible outfits. Okay, here's another example, telephone digits. And let's assume that we can use the digits 0 through 9. Okay, now here in the United States, we use, excluding the area code, 7 digits. So we have 7 spaces. And for the first space, we can use the digits 0 through 9. So we have a total of 10 options. 1 through 9, which is 9, and then the 0. So 10 options. Now, there's no restrictions on the second space. It doesn't say that you can or can't repeat. So I'm going to assume that you can repeat numbers here. So then for the second space, I can use 0 through 9 again, so that's 10. And then the third space, 10. And each one of these, 10 options. So then the answer is 10 to the 7th power, or 10 million different phone numbers, possible phone numbers. Okay, here's another option, or another example. All right. How many different license plates are possible given that there are 6 spots that you can use for the license plate? And the first 3 spots have to be letters, and the last 3 spots have to be numbers. So 1, 2, 3. Okay? And once again, I'm going to make the assumption that the letters can repeat and that the digits can also repeat. All right. So in the first spot, when it comes to the letters, I can use all 26 letters from A all the way to Z. The second spot, same thing. So 26 options and 26 options. Now, when it comes to the numbers, the first space, I can use the digits 0 through 9. So that's a total of 10 possibilities, 10 options, and then times 10 options, times 10 options. And so I get 26 to the 3rd times 10 to the 3rd, which is equal to 17,576,000. So this is million possible license plates. So let me give you another example here. All right, let's take the scenario of a test, a true or false test. So let's assume that we don't know any of the questions. We don't know the answer to any of the questions. What are the chances of getting everything right? All right, well, how many different results can occur if there are only 4 problems? All right, well, 4 problems, I have 4 spaces here. What are the options for problem number 1? It's either true or false, so 2 options. For problem number 2, 2 options. Problem number 3, 2 options, and problem number 4, 2 options. Okay, so if I multiply all these, I get the answer 2 to the 4, or 16. So 16 possible results that I get them all right would be 1 out of 16. But the number of possibilities, though, of possible results is 16, the total number. Okay, in this next example, let me go back to the telephone number, but this time with restrictions. And the restrictions are, well, actually one restriction here, that you can't start this telephone number with the digit 0. Okay. All right, so if I can't use 0 in the first position, well, that only leaves 9 options here. Okay, but there's no other restriction, so the other numbers can include 0. So 10 options for the second, for the third, and the rest. So then the answer is going to be 9 times 10 times 10 times 10 times all the way. You multiply all these and you get 9 times 10 to the 6, or 9 million possibilities. And that is all.